All right, so in this lesson, I introduced the concept of molecular formulas. And so while the empirical formula is the simplest whole number ratio of atoms in a molecule, the molecular formula is how that molecule actually exists in the real world. Now, sometimes the empirical and the molecular formula can be the same, but often it is not. So let's look at this first example of how to take an empirical formula and determine the molecular formula. So what you're going to need to do is you are going to take the molar mass of the molecular formula, which is 116.1, and you need to divide it by the molar mass of the empirical formula, which is right here. So I need to determine that first. So I'm going to take the molar mass of carbon, 12.011, and I'm going to multiply that by 2. Then I'm going to add to that the molar mass of hydrogen, 1.008, multiply that by 4. And then I'm going to add to that the molar mass of nitrogen, 14.007, plus the molar mass of oxygen, 15.999. And so what I get for the molar mass of the empirical formula is 58.06. So when I divide this, the value that I get, the whole number integer that I get, is 2. And so what I need to do now is I need to take my empirical formula, and I'm going to take each of the subscripts and multiply it by this integer. So here now, instead of C2, it's going to be C4, because I multiplied 2 by 2. Instead of H4, it's now going to be H8. Instead of N1, an implied 1, it's going to be N2. And instead of O1, it's going to be O2. So that is my molecular formula. Okay? So those aren't too bad going from empirical directly to molecular. What if I were not nice, though, and I didn't give you the empirical formula and I did not give you the molecular formula? Well, in that case, then, you would first have to determine the empirical formula, and then you would have to determine the molecular formula. So let's do that. In this problem, it tells me I've got 26.7% phosphorus, 12.1% nitrogen, and 61.2% chlorine. So I'm going to take each of these, assume that I have 100 grams, so then I can just convert the percents into grams of each of these. 12.1 grams of nitrogen, 61.2 grams of chlorine, and I'm going to convert each of these into moles because the empirical formula, the subscripts in it, represent the ratio of your number of moles. So I'm going to get out of grams, we're putting them on bottom, and I'm going to get into moles. And in order to do that, I need to put the molar mass of each of these atoms. Okay? So the molar mass of phosphorus is 30.974. The molar mass of nitrogen is 14.007. And the molar mass of chlorine is 35.453. Okay? And then it's going to be 1 mole for each of these, because it's that many grams per mole is your molar mass. Okay? So now I'm going to do some division. 26.7 divided by 30.974, I get 0.862 moles. Okay. Doing the same thing for nitrogen, 12.1 divided by 14.007, I get 0.8639 moles. And then when I take 61.2 and divide that by 35.453, I get 1.7263 moles. So I'm going to divide now by my smallest number of moles in order to determine the mole ratio. And that ratio will be my subscripts that I'm about to write. Okay. So obviously for the first one, this is going to be 1 because I'm dividing by itself. If I take 0.8639 and divide by 0.862, I get 1.002, so I can be safe to assume that that's 1. 1.7263 divided by 0.862 gives me 2.003, so I'm safe assuming that that is 2. So what I end up getting is P1, N1, Cl, and my subscript is a 2. So that is my empirical formula. Now, your empirical formula, this is the simplest whole number ratio, but that is not necessarily how that compound exists in the real world. So in order to determine how that compound exists in the real world, what I now need to do is take the molar mass of the molecular formula, which is 695, and I'm going to divide it by the molar mass of my empirical formula, which is 1 phosphorus, so 30.974, plus the molar mass of nitrogen, which is 14.007, plus the molar mass of chlorine, 35.453 times 2, and I get 115.887. So I'm going to take 695 and divide by that answer. And what I end up getting is 5.997, so that's going to be 6. Keep in mind, when I do this division, I should be getting a whole number, and if I'm not, then I probably did something wrong in my problem. Okay? So this is going to be my multiplier. So instead of P1 for my molecular formula, it's going to be P6 N6, because I multiply 1 by 6, and then Cl12. Okay, so that is my empirical and my molecular formulas.